Now in some of my other videos, I showed all of you how I built a PlayStation controller for my quadriplegic nephew. So what you see in front of me is what we built in those videos. It's a wooden box with joysticks and buttons on it, and it does the exact same thing as a DualShock PlayStation controller. Now in those videos, I had mentioned a few times that I was working on a completely different design that's more flexible, a little bit more modular than this controller. And I'm excited to show that to you today. So let me get it out and we'll see what it looks like. Right here is the new and improved modular controller that I've been working on. So instead of having buttons and switches, joysticks permanently mounted to a box, what I've done is made the entire thing flexible so that we can plug in any kind of button or switch or joystick into this thing and use it as we need it. So for example, I have a simple switch here. So this is just an on and off switch, similar to what the arcade button is that we used in our previous joystick or previous controller. And it's going to plug into one of these 3.5mm jacks. Now each one of these 3.5mm jacks corresponds to a button on a controller. So for example, it could be X, square, triangle, circle, or it may be the directional pad or the L1, L2, R2, R1 buttons. Anything on the controller, we have those as 3.5mm sockets. So I can use any type of switch to control any type of button. So if I wanted to use this switch for the X button on a PlayStation controller, for example, then I can plug it into the X button jack and then I can mount it anywhere I want to. So I could have it mounted to my wheelchair armrest and maybe use my elbow to control it. I could put it in my mouth and bite on it if I wanted to, or maybe up by my head so I could use my head to activate this switch. Now, we're not only limited to joysticks and simple button switches like this. We could also use more complex things like a sit-puff device, or we could come up with our own types of switch. You're really only limited to your imagination, so you can expand this to whatever you want to suit your needs. Now, the other cool thing about this controller is I have made it to where we can use it with any system. So what I have done is I've created a module. And this module I built for the Sega Genesis Mini, or the Sega Genesis Classic Mini might be what it's called, but it's like a, one of the mini systems. I know they made one for Super Nintendo and regular Nintendo. This is the Sega Genesis version. So if I wanted to use this controller for a Sega Genesis Mini, for example, I can plug this module into this connector right here on my modular controller. So this would plug in like so, and then the other cable coming out of this module would plug into the Sega Genesis Mini, and then I can plug in my switches and joysticks however I need to use it, and use it on that Sega Genesis Mini. Now we can build modules for absolutely any gaming system out there. In the previous wooden box controller that we made, I used the Brook wireless fighting board to connect to a PS4, a Nintendo Switch, or a PC. We can make a separate module using that Brook wireless fighting board and have the exact same capability that we had in the previous controller. And then if we wanted to, let's say we wanted to play one of the older systems, so if you're like me and you grew up with Nintendo, you could make a module to connect to a original regular Nintendo if you wanted to, or Super Nintendo, or an N64, anything you want. We can build a module for that, plug it in, and then we can play on that system. But wait, there's more. I started with the gaming systems because that was readily available. It's been done before, so it was a lot easier to get started with the gaming systems. But we could make modules for things that have nothing to do with gaming. So we could use it for an RC car, for example, and a remote control car or truck. If you wanted to get into that, we could make a module for a controller like that and then use our buttons and joysticks as necessary to control that. We could do the same thing with flying drones. We could hack into a drone controller and make a modular out of it, and then we can control drones with our own buttons and joysticks and stuff. So long-term vision, I want to use this like a universal remote, if you will. So the buttons and the joysticks that we use to control a PlayStation can also be used to control a multitude of other things. Now, this modular controller was inspired by the Microsoft Adaptive Controller. If you're not familiar with the Microsoft Adaptive Controller, it also uses the 3.5mm jacks, and I made sure that my controller, anything that we plug into this controller, will also work for the Microsoft Adaptive Controller. So for those of you who already have a Microsoft Adaptive Controller, you may not be interested in this box right now, but you might be interested in the buttons and switches that we build for this controller. So that's one thing that I'm going to start doing here fairly soon, is start building my own buttons and switches that we can use in different locations. And whatever we make for this controller will also work for the Microsoft Adaptive Controller. So some of you might be interested in some of those devices. So that's the plan. Now this video, I'm going to walk you through exactly how I built this box, what's inside of it. And then this probably isn't going to be the final design. This was a proof of concept prototype. I got some bugs to work out on this, but we're going to start building more modules. We'll start testing this guy, and then we'll start tweaking it and making it useful for different things that we need to use it for. Hope you enjoy. Hope you learned something. Thanks for watching. Let's take a minute to talk about the buttons and switches and all the stuff that we're going to plug into this modular controller. How does it work? How do we interface with it? Where do we get them? Logitech makes a kit, I can't remember, what's it called? Adaptive Gaming Kit for the Microsoft Adaptive Controller. And I bought a used one off of eBay for about $60. Now if you bought this new, it's right at $100, or it is of the time of me making this video. Who knows with supply and demand issues and COVID and whatnot if that's changed, but it's about $100 right now. And I've not really opened this to see if it even has anything in it. I hope I didn't get taken advantage of by the people at eBay. It looks like there's all kinds of different switches in here, which is cool. There's more in here than I thought there would be. The question is, does it work? Okay, well that's cool. It looks like I got a sticker pad. I can pull those stickers off and label stuff. Ooh, this is nice. I think this is a pad maybe that these buttons stick to, like a Velcro pad of some kind. I don't know, there's multiple ones in here. Yep, here we go. So here's some Velcro strips that come with it, so I can, I guess, cut those up and stick them to my buttons, and then they'll stick on this pad. Well, that's nice. Instructions, decals. Don't know what that is. Yeah, so this is one option. You can purchase this kit, and it should work with the Microsoft controller, obviously. And I also want it to work with my controller. So this is what I'm going to start with when I get the controller working. I'm just going to use some of these Logitech switches to test it. And then once I confirm that all my stuff works with my controller, then I'll get a little more adventurous and start making my own buttons and switches and joysticks and whatever we need. But I did want to show you how it works. And again, I don't have the Microsoft controller, so there's nothing that I can really test it on, unfortunately, but I did do some research. And Adafruit has got a pretty all-inclusive rundown of how the Microsoft Adaptive Controller works, and they sell some buttons or kind of DIY buttons that you can make yourself and use with that controller. And they go through great detail on the 3.5mm audio connections that they use. But after looking at this is a little bit different than what Adafruit has on their website. And I honestly don't know if it even makes a difference. So a 3.5mm jack is this right here. And it's what you would see on a pair of headphones or a microphone if you plug a microphone into your computer, that sort of thing. That's the exact same thing. Now this one that I hold in my hand is what would be considered a mono plug because there's only 2 contacts on it. And you can tell that by this ring right here. So this ring is like an insulator or a separator between the 2 contacts. Everything above the ring is 1 contact, and everything below the ring is a second contact. So this is a 2-contact switch. This makes sense. This is what I would expect the switches to be because we only need 2 contacts, 1 for signal and 1 for ground. And then when you push the switch, it connects those 2 together. So a mono plug like this one makes absolute sense. The other kind, the one that you're more typically used to seeing, the kind that you probably use more often that would be on a set of headphones, has 3 contacts on it. And I have not got one of those here. Let me see if I can find an example of that. The kind of plug that you're more used to seeing is probably from headphones, and that plug looks like this. So it looks almost identical to the mono one, or what I call the mono one. This one has 2 insulating rings on it and 3 contacts. So you've got a contact at the top, and then you've got an insulating ring separating it from the second contact. This middle silver section right here is the second contact, and then you've got a second ring, insulating ring, separating that. And then this third silver section down at the bottom is a third contact. So on your headphones, you've got left ear, right ear, and then you have ground. That's why there's 3. This is the one that Adafruit has in their layout. And so I kind of thought that the Logitech signals would look like this instead of the mono one. Now you could still use this for what we're trying to do. You just wouldn't use one of the contacts. You're only using 2 out of the 3. And that's okay. I'm curious if you can plug a plug like this one into a mono socket and it still works the same way. I'd be willing to bet that it does. I imagine that you can interchange them. So I'm going to try that later and see what the difference is. This is called a TRS plug, by the way. I don't know what the mono one's called, but I know that this is a TRS. And this guy is what they use for the analog signals. So the mono one's for the switches. They're very simple. It's just on or off. Same idea for the analog joysticks, or analog joysticks. This guy is a TRRS, and it's the same form factor, still 3.5mm plug, but This one has 4 contacts on it. So once again, you have 3 insulating rings and 4 contacts. So the very top one is a contact, you have 2 center contacts, and then you have 1 at the bottom. The reason that these are used for analog is because the analog signals require a signal for the x-axis, a signal for the y-axis, and then you need a reference voltage and you need a ground. So that's 4 contacts. A TRRS plug has 4 contacts on it, so that makes complete sense. So that's what we're going to use for our controller. Pretty simple. It's very compact design. It makes perfect sense to use that type of plug. I purchased all of this on Amazon, of course. I purchased 2 different kinds of jacks. Sockets? Jacks? Sockets? I don't know the technical name. The female part of the 3.5mm plug. I bought 2 different kinds. So because I expected, per the Adafruit design, I expected the plugs to be like this, so 3 contacts. I purchased a 3 contact socket. So this guy plugs in here. This would be like the receiving end of your phone or your radio or your Walkman or your CD player or whatever the kids are using these days. And on the back end are your 3 contacts. Just like I said, so these 3 contacts correspond to these 3 terminals. These 3 terminals are what we're going to wire our signals up to, our switches or whatever. We're going to use 2 of the 3 wires. We're going to use 1 for ground, and then we're going to use 1 for the positive signal. And then we're going to have 1 of these for each button on our joystick. I think the most complex joystick that we need to interface with is the PS4 controller or the Xbox controller. They're very similar. So we need enough of these to accommodate every button on those joysticks. And then the second jack or socket that I have is the 4-terminal kind. So that's for our analog buttons. That will be used to plug in our analog signals with the 4 contacts here. So as you see on the back end, there are 4 contacts associated with that. And for these, we'll use all 4 contacts. We'll have 4 wires coming off of it and going to our joystick or brookboard or whatever it is that we need to control. So that's the basics to how we're going to interface our buttons and joysticks with our controller. Now I just need to figure out how to wire it up. Now I'm not a big fan of soldering. I like soldering, I'm just not real good at it. So I try to minimize it as much as I can. In this case, I didn't really have an option. So I'm going to have to solder wires on every one of these little bitty terminals. And I've been dreading it, but I'm just going to have to do it and get it done. Now the good thing is we're going to have a common ground across all of our buttons and switches. So we can just daisy chain grounds from one to the next. We don't need a ground wire running individually to our connection or our interface connector. So I need to figure out how I'm going to do that. I'd like to keep it as clean as possible and avoid the huge rat's nest wiring that I usually do. I'm going to try and make it a little bit cleaner this time. I'll lay it all out. I'm going to get some of these installed and then I'll bring you in and show you kind of what I'm talking about. I did a little probing with my beat meter here. I went ahead and plugged one of these mono switches into a stereo jack, the TRS jack that I have. And it does work. You can plug the 2 together and it makes complete sense. What happens is the one terminal, so there's 3 terminals on the back of this, but remember there's only 2 terminals, 2 contacts on the switch plug itself. And what happens is one of the terminals, which I'll just grab the top terminal here, one of the terminals is connected all the time, and the other side is not connected at all until you push the switch. So this is not connected when the switch is open, and then when you press the switch, that terminal is now closed. And you could do the same with the 4 contact plug. You could also plug it in to a 3 contact. You're just going to have 3 out of the 4 available. So anyway, learn something new today. We're going to go away from the wooden platform, and I'm going to use a sheet metal box, which I have here. This is a box made by Bud Industries. They're oftentimes called Bud boxes. And this is a 10 by 17 aluminum box. So we're going to start with that, and the next step we're going to do is drill holes into our box to attach our features. And in order to do that, what I did, I drew up hole patterns in CAD. Now I use CAD because I have CAD and I know how to use it. If you're not comfortable with CAD, you don't have to use a CAD program. You could use PowerPoint, you could use Microsoft Word. If you're really old school, you can measure stuff out with a ruler and a pencil and just mark your holes where you want them. Or if you're a crazy person, you can just take a drill and start drilling at random. It's your controller, you do you. But what I'm going to do is I'm going to cut these patterns out, and then I'm going to tape them in the locations that I want, and then I'm going to cut them out with a tool of some kind. So let me get these cut out and I'll show you what I'm talking about. Alright, we got that done. So what I did is I cut out my patterns. I've got 2 slots that I need to cut out, so I cut slots out here, and then I'll take a permanent marker and I'll trace around that. Same here, I've got a slot that I need to cut out of the sheet metal, so I'll take a Sharpie and mark around that as well. And then the rest of them are holes, so I've got these will be my button connectors here, all of these holes. These are going to be the RJ45 or Cat6, Cat5 connectors in this slot here. And then this guy is going to be the HDMI plug here. And then on the top I've got 4 holes for LED lights. First I'm going to mark my slots with Sharpie, and then I'm going to go through and punch. I'm going to take just a hammer and a punch, and I'm going to put my punch in the middle of each one of these circles that I have for hole patterns. I'm just going to tap it, and that'll give me the center of each circle, and then I'm going to go through and take a drill and a drill bit and drill through all of those holes. I did mark on my drawing the diameter of each hole size, just so it's there and I don't have to look it up whenever I do go to drill holes. Once I get that done, I'm going to peel all the paper off, and then what will be left are rectangles outlined in Sharpie. And I'm going to take a jigsaw and cut those out. It'll either be a jigsaw or a Dremel tool, most likely. Not really sure how I'm going to do it, but it's going to be one of those 2 tools. You could use a hacksaw, you could use a little handsaw blade. I personally am a big fan of power tools. I'm pretty lazy, so if I have a motor on it and I can just zip, 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 that's what I'm going to do. Remember, when you're making hole sizes like this, it's a lot easier to remove material than it is to add more material if you make the slot too big. So always err to the small size, and if your widget doesn't fit in the slot the first time, you can always take a file and file the hole a little bit larger. If you make the hole too large, you're just stuck with that unless you're a really good welder and want to take time to weld material back. If that's the case, then good for you. But I would recommend erring to the small side. So that's what I'm going to do. I'll be back. I've got the holes larger, and my devices now fit inside the holes. I did have to remove the little Cat 6 connector, Keystone connector plate. It came with little push pins that are supposed to go in the holes, and that didn't line up exactly like it needs to, so I just knocked those out, and I'm going to use regular screws in my holes with nuts on the back side, and then that'll fix that problem. When I first came up with this concept, my plan was to use an HDMI connector to connect different controllers into my modular controller. So just for example, you could hack into multiple controllers like a Super Nintendo or a Sega Genesis or an N64, and you could interface that controller with the modular section of the controller via HDMI. And I thought I was being really clever because HDMI is cheap and everybody has HDMI cables, and there are 20 pins inside of an HDMI cable. However, I had never cut an HDMI cable in half, so I didn't really know what was inside of it. I just assumed that there were 20 separate wires since there's 20 different pins. However, when I was working a controller mod in parallel to this guy, and during that mod I cut a HDMI cable in half, and I learned all kinds of things. There are 20 wires inside of an HDMI cable, but the HDMI cables are heavily shielded, so there's a lot of like aluminum foil type material that the wires are wrapped in. There's several twisted pairs that are individually wrapped in foil, and those twisted pairs have an uninsulated wire running alongside of them. And that's all well and good, except each one of those uninsulated wires counts as a pin. So there's like 4 or 5 of those, which means that there's only, well, assuming there's 5 of them, there's 15 insulated wires. For what we need all the wires to be insulated, because if the wires are bumping into each other, if the uninsulated wires are touching ground or whatever, those are going to short out. And it's not going to cause a fire or anything, but it is going to cause our controller to do things that we don't intend it to do. So, as a result, the whole HDMI concept is just not going to work, and we're going to throw it in the trash. I had to go back to the drawing board, figure out a different solution, and I did come up with one. So instead of the HDMI concept, we're going to use a D-sub 25 connector. And I went ahead and I've already 3D printed a new faceplate. Now, I've already cut my holes in my box, so I have to make do with what I have. So I use a 3D printed faceplate, which is probably the easiest way to do it, but had I not already cut holes that I have to accommodate, you could potentially mount it directly into the box itself, or create another piece of sheet metal and stamp it out. I don't know. Anyway, I got that figured out. I bought this off of Amazon. It's a little bit more expensive than the HDMI one I had, but not unreasonable. And then I also got a cable that goes along with this. So these are, I don't want to say obsolete because people still do use them, but you used to see them a lot more often on old school printers, used connections like this, anything with old analog signals. In the past decade or so, everything has switched to USB, which is a digital signal, and HDMI is also a digital signal, which is why it's very shielded and the wires are smaller. So switching over to this connector is actually probably smarter. I mean, it's intended to be used for what we're using it for. The downside is you probably don't have a cable like this laying around your house. I mean, I didn't, and I have all kinds of computer crap sitting in my closet. So I had to buy one. Fortunately, the cables are readily available, and they're about the same price as an HDMI, so it's not too bad. It's just not what I originally intended. It's also bigger, so an HDMI cable would have been a lot smaller in our box. This is quite a bit wider, and it doesn't look as sleek and pretty, but in the long run, it's probably a better solution. So I'm gonna mount this guy in the box now, and then we've got our Cat 6 connector Keystone mount thing. We got to get that mounted in, and then I'm gonna start mounting the things that the joysticks plug into. All right, I've got a couple or 3 of my 3.5mm TRS jacks in place, and I'm starting to solder ground wires to them. I wanted to take this opportunity to show you what I meant by daisy chaining the ground wires. So we don't need to run individual ground wires from every jack to our D-sub connector. We just need to connect all the grounds together on all of these jacks, and this will continue on through all the jacks that we have in the box. And then when we're done, we will take the remaining wire and run just that one wire to the D-sub connector. If you're trying this for the first time, you've never soldered before, don't get frustrated if it's not working for you the first time. It took me several tries in order to figure it out, and I'm still learning myself, but it just takes practice. But I did want to show you kind of the method I'm using to put these together. It seems to be working okay. I pre-cut little strips, they're all the same length, and I went ahead and stripped each end of the wire. And I'm just going to take the 2 wires and I'm going to wrap them around each other and kind of twist them. Now the wire isn't very long, so you're not going to twist it too much. And then just going to hold them down with a piece of tape, just like that. Then I'm going to take my soldering iron and solder. And I'm going to take the soldering iron and I'm going to hold it underneath of this bare wire. And all we're going to do is heat up that wire. I'm not putting any solder on it. And then I'm going to touch the solder to the wire. And once that wire gets hot enough, the solder is going to melt into it. See there? Solder is just going to flow right through that wire, and it's going to solder the 2 wires together. Okay, then we can take our tape off. And then I'm going to solder, I'm going to put a little bit of solder on my 3.5mm jack tab. So the long tab, at least on these jacks that I'm using, the long tab is the ground. So again, I'm going to put my soldering iron underneath the tab, or no, I'm sorry. I'm going to put the soldering iron on top of the tab, and I'm just going to heat it up. And then I'm going to touch the tab with the solder. And the solder is going to melt right on there and flow across the tab. And there you go. And then the last thing I'm going to do is take that twisted pair of wires. I'm going to hold it on top of that tab that I just soldered. And I'm going to put the soldering iron on top of that wire. And it's going to transfer heat through the wire down to the tab, and it's going to melt that melt the solder together between the wires and the tab. So I'm just going to put a little bit of pressure on top of the wires. and it's all going to melt together, and then I'm going to lift up, let the solder cool, and there you have a soldered connection. That seems to be working for me okay. I don't know if that's right or wrong, but if it works, then I go with it. So that's how I'm doing it. Feel free to do whatever works for you and let me know. This was handy. I just installed the jacks into my box backwards so that I have access and the box holds everything in place. That's working really well. I'm going to continue doing this all the way around, and then I need to attach individual wires to the second tab, and each one of those wires will be the positive signal, and each one of those will run to our D-sub connector. Got some updates. I got all my wires soldered up. It's about 485 solder connections. I flipped my sockets over. So remember, I was soldering them on the outside. I flipped everything back over after I got them all soldered up. I'm only working with 5 different colors of wire, so I did try to do it somewhat smart. And I did green wire, white wire, blue wire, yellow wire, green wire, white wire, blue wire, yellow wire. And then I ran all my wires to my D-sub connector breakout board, and I bundled them. I twisted them together just on rows. So this bundle right here is the top row. This bundle right here is the bottom row, and then this bundle over here is my analog signals. I'm doing something that I've never done before, and that's trying to keep my wires somewhat clean. And then I just taped them together to keep the bundles together. Now I do have some tie down straps that I'm going to put in here to keep everything in place. I also numbered my pins, starting at 2 because my D-sub connector pin number 1 is ground, so we're not using it for any signals. So these numbers correspond to the pin numbers on my D-sub connector, which are labeled here. Underneath these wires are numbers, and those numbers correspond to pin numbers on the D-sub connector itself. So I diagrammed all of this. I figured out what all the controllers are that I want to work with. Basically, I took the PS4 controller, laid out what pins I needed for that one, and then all the other controllers fall out of that because the PS4 controller has the most signals coming out of it, so I needed to accommodate that, and then the rest of them are easy. It doesn't really matter how you wire it as long as you stay consistent. So I didn't pick pin numbers based on anything intelligent. I kind of randomized it. I did try to keep the D-pads, directional pads together, like up, down, left, right, down, up, down, left, right. Those 4 are in a row here. For the PS4, the X, square, triangle, circle, I kept all those together. So I did kind of try to make it smart, but other than that, it doesn't matter what pins you use. Just record what you do so that when you wire up the interfaces, you can be consistent and you get what you need. Now the numbering that I showed you, this numbering here, eventually maybe we'll do something smarter, but like in the case of the adaptive controller, when you're only doing one controller for Xbox, you can label them up, down, left, right, start, select, X, A. I don't know what all the buttons are on a Xbox controller, but it's easy to do that. When you're making one controller for a bunch of different gaming systems that all use different button names, that makes it much, much more difficult. That's why I just went with the numbering system, and then later I might think of something more clever. I did have an extra pin, so we're only using 23 out of the 25 pins on our D-sub connector. I kept pin number 13 blank for some reason. So that extra wire here, I just grouped in here. I also added 2 extra analog signals that are not needed, and we don't have enough pins over here to accommodate them. I did that just for future use. I'm not sure how this is all going to work, so I just added that now, and I bundled all those extra wires over here, and they're just going to be here out of the way. The other two analog signals run here, and that's going to be the left and right toggles on a PS4 or an Xbox. Got the tie straps down, so I tied my cable in here so it's not flopping around so bad. And then I also added my RJ45 Cat 6 Keystone connectors in here. No, I'm not going to hook these up to anything right now. These are for future expansion, potential try some new things in the future type deal. So right now we're going to leave these blank. I'm going to put the top on it, and then I think we're ready to try it out. I'm not sure the best way to record this. I'm no Spielberg, so I don't know how to show a laptop screen and what I'm doing here at the same time. So you're just going to have to bear with me. But got the controller all together. This is a Sega Genesis mini controller interface box that we built in a different video. So if you want to see that, check it out. But inside of here is a Sega Genesis mini controller that we hacked into, and then we ran all the signals out into our D-Sub 25 connector. And then the other cable coming out of that is the USB cable that would normally interface with a Sega Genesis Mini. But for testing, I want to use the laptop since it is a USB interface so I can see what's actually going on. And then I took all the Logitech adaptive controller buttons out of my adaptive controller kit, and I plugged those into the signals that are being used for the Sega Genesis Mini. You can see that I've labeled all the buttons that are on this controller with the pin numbers, so I just plugged in these switches to the corresponding pin numbers. Unfortunately, I don't have enough buttons to accommodate all the pins, all the buttons on my controller, but that's okay. For this test, we just want to see that it's working. So on my laptop screen, it may be hard to see, but these rows of red down here are the buttons that the laptop is seeing. So when I push one of these buttons, one of the buttons should glow red, and it is. So that button right there, when I press this button, is glowing red. So that's good. That means that the controller that we have in here is communicating with the laptop. We also know that the signals coming out of our controller into our D-Sub 25 connector is reading what we have in our box. So that's all is good. So that button is working, that button is working, that button is working, that button's working, that button's working, that button's working. Oh, that's a directional pad. So when I push this button, that's the directional pad down. So my little arrow in this box is going down to the bottom of the box. So that's working. That's up. And then that's another button. So all the buttons that I have hooked up are working. That's all goodness. I did notice a couple problems when I was hooking this up. One, the D-Sub connector that I have coming out on my controller is not plugging fully into the female connector that we have on our box. And that's because the 3D printed panel that I made to mate it all together is too thick, and so it's not allowing the two connectors to fit completely like they're supposed to. However, they are plugged in good enough for it to work, obviously, so that's good. So that's something that I gotta fix later. I also had difficulty plugging in these switches into my audio jacks. The audio jacks that I'm using, I used the cheapest ones that I could find, and I'm starting to understand why they're the cheapest I can find. So in the future, when I build another one of these, I'm going to have to find better quality audio jacks. But for now, we're going to make do with what we have because this is just a proof of concept. So it's looking good. It looks like this is actually going to work. Now I need to build other controllers so that I can test the analog functions and do more interface switches, and we got a lot of work to do. This is exciting. We've shown that the concept works, which is fantastic. We still have a lot of work to do. The next steps are to build more controllers. So I built a really simple one with the Sega Genesis Mini. I'm going to try that on the actual Sega Genesis Mini, but it should work. We proved that it worked on a laptop, so there's no reason that it won't work on the Sega Genesis Mini. The next step, I believe, I'm going to build another one of those boxes like I did for the Sega Genesis Mini, but use a Brook board instead so that I can connect to a PS4 and a Nintendo Switch and also a PC. And that's going to be more complicated. That's going to allow us to test the analog jacks, and it's going to pretty much use every connector across the board, so that'll give us a chance to test everything. We'll test that on the PC first, and then we'll connect it to an actual PS4 and go from there. The other things that I want to do is start building my own buttons and joysticks and different things that we can use to interface with this guy. Now there are some limitations, some differences between this controller and the Microsoft Adaptive Controller. From my understanding, the Microsoft Adaptive Controller allows different button mapping within software. So you can plug in your stuff and then you can map that inside the software to whatever you want. We don't have that capability here because that requires software, and there's no software inside of this box. It's very simple. You can kind of do that by unplugging buttons and plugging them into whatever button interface that you want to. You can remap them that way, but I understand that that's more difficult for disabled people, plugging and unplugging, so I get that. That's something that we could potentially add in the future. It's going to add complexity and cost. I'm not sure I see the complete advantage there because I think, and I could be wrong on this, but I think the later systems allow you to remap buttons inside of the gaming system itself. I know PC you can do that. I thought you could do that on Xbox, and I thought PS4 could also do that. So that's something to consider. Now obviously the older systems, that's definitely not an option, like the Nintendo and Super Nintendo and the Sega Genesis Mini. Those kind of systems never had button remapping. The other thing that this controller doesn't have, on the Microsoft Adaptive Controller, there are two USB interfaces that allow you to plug in any USB joystick and use those. Again, that requires software, which we do not have in this system. I am going to build some joysticks that we can use. So I don't know. I guess the big limitation there would be as if there is an existing joystick that is really helpful to you that's a USB interface, we won't be able to use that. However, if you do use a PC, I'm pretty sure that you can plug this controller into the PC and also a different joystick if you have multiple USB ports, which you most likely do, and then you could use those together. Not 100% sure, but it's something that you could try. The third thing that this controller cannot do is use a gaming system controller along with this modular controller. So I know the Xbox Adaptive Controller, you can use an Xbox controller and the adaptive controller simultaneously. We're not going to be able to do that with this one. Again, you could probably work around that on a PC, but not an Xbox or a PS4. However, again, I'm going to show you how to build different joysticks and thumbsticks. I know a lot of people like to use the thumbsticks on the controller and then the buttons on the adaptive controller. There are ways to do the exact same thing with this controller. So those are some of the limitations. However, given that we're building this ourselves, we can expand on it all we want, and we can do so much more with this than what we'll ever be able to do with the Microsoft controller. And give me some ideas. I want to hear what you think. Start thinking about interface things that you want to see, buttons, joysticks, sit puff devices, scroll bars, I don't know, touchpads. I want to get your idea, a feel for what would help you. Help me help you help yourself. So I'm looking for ideas. Please drop those down in the comments. Please like and subscribe if you haven't already. I really appreciate it. And I'm going to put all the components that I used inside of this box down in the description. Now this is not going to be the final design. This is just a proof of concept. I want to get a feel for how this stuff works, and then later I'll build another one. Could be a little bit smaller. We could definitely go a smaller package. I built this size because I thought that I would use the top platform to hold the buttons and joysticks. I'm gonna play with that and see if that's feasible. If it's not, then I can make this much smaller, you know, something like this size, and that would reduce the cost, and it would also make it a little bit easier to travel with. Something to think about. Let me know your thoughts, and I'll see you next time. Thanks.